So today we're going to look at another method of classifying triangles based on the lengths of their sides. Given that a triangle has three sides, any given triangle can either have three congruent sides, two congruent sides, or no congruent sides. So first we're going to take a look at a triangle with three congruent sides. Does anyone know the name, the generic name of a triangle that has three congruent sides?
Is it an equilateral?
It is an equilateral. Very good, Sarah. So looking at this diagram right here that I've drawn on the board, what do you notice about the interior angles of an equilateral triangle?
They all look the same.
Very good, Sarah. All the angles in an equilateral triangle are congruent. So equilateral triangles have three congruent sides and three congruent angles. Given what we learned yesterday, that the sum of all the angles in any triangle has to add up to 180 degrees, and knowing what we just learned that all the angles in an equilateral triangle are congruent, can we figure out what the measure of any individual angle in an equilateral triangle is? I'll give you a couple of seconds to work on that.
Is it 60 degrees?
It is 60. Very good, Anna. So to recap, an equilateral triangle has three congruent sides and three congruent angles, each of which is equal to 60 degrees. So now we're going to look at the second type of triangle that has two congruent sides. Does anyone know the generic name of a triangle that has two congruent sides?
Is it an isosceles?
It is an isosceles triangle. Very good, Sarah. So isosceles triangles have two congruent sides. Looking at this diagram right here, what do you notice about the interior angles of an isosceles triangle?
Two of them are the same.
Two of them are the same. So isosceles triangles have two congruent sides and two congruent angles. Now we're going to move on to the third type of triangle. This type of triangle has no congruent sides. Does anyone know the generic name of a triangle that has no congruent sides?
Is it a scalene triangle?
It is a scalene triangle. Well done, Anna. So, looking back, given what we know that equilateral triangles have three congruent sides and three congruent angles, isosceles triangles have two congruent sides and two congruent angles, and scalene triangles have no congruent sides, what can we infer about the interior angles of a scalene triangle?
None of the angles are congruent.
Very good, Sarah. Scalene triangles have no congruent sides and no congruent angles. So this is another method of classifying triangles based on their side length. Does anyone have any questions about equilateral, isosceles, or scalene triangles before we move on? Yes, Erin.
What's the funky little S thing that you have inside the equilateral triangle?
What's the funky little S thing inside the equilateral triangle? The S's in this case are just representing the measurement of the interior angles. Since all of the interior angles of an equilateral triangle are congruent, each one is denoted with the same letter S. So I set, since we know that the sum of the angles in a triangle is 180 degrees, I set 180 equal to S plus S plus S and used simple algebra to solve for 60 degrees. Each of the angles in an equilateral triangle is 60 degrees, which Anna helped us out with earlier.
Okay.
Are there any other questions? Hey, it's an equilateral.
Hey, it's an equilateral.
Equal sides and angles in general.
Equal sides and angles in general.
Check it out. We've got an isosceles.
Check it out. We've got an isosceles.
And it's got two sides that are equal length.
And it's got two sides that are equal length.
But hey, what about scalene triangles?
But hey, what about scalene triangles?
No congruent sides or equal angles.
No congruent sides or equal angles.
Well done, guys. Thank you.